Hi guys. Someone had a question about why it's on the continuity is on a closed interval and the differentiability is on the open interval. And so I wanted to do an example. One example could be using the function f of x equals the square root of x. Okay, so if I take the derivative of the square root of x, it's 1/2 x to the negative 1/2, which is 1 over 2 times the square root of x. And I can see that it is not differentiable at 0. At x equals 0. So this function has a domain with bracket 0 to infinity, but your derivative has a domain of parentheses 0 to infinity, okay? But the mean value theorem still works. So let's say I wanted you to, check however they're wording it, check the hypothesis of the mean value theorem on the closed interval from 0 to 4, let's say. If, is there a c on this interval such that it is equivalent to the slope of the secant line? Okay, do you see how it's continuous on the closed interval, but yet differentiable on the open interval, and we can still use the mean value theorem, okay? So there are certain cases like that where you have to make sure that, it doesn't have to be differentiable on the closed interval because we don't have differentiability there at that endpoint. But as long as it's continuous on those endpoints, differentiable on the open interval, and then we can still use the mean value theorem because, we can say that we are wanting our f of b minus f of a. So this would be square root of 4 minus square root of 0 over 4 minus 0. We want that to equal 1 over 2 times the square root of c, because we're setting our f of b minus f of a equal to our f prime at c. And so this would be 2/4 equals 1 over 2 times the square root of c. So of course 2/4 is 1/2 equals 1 over 2 times the square root of c. And I can see that my c has to be 1, but if you cross multiply and then divide by 2 on both sides, square both sides, then your c has to be 1. And so, well, I guess about right there, since that's 4. Oops, accidentally lost my whole function there. There we go. If we took the slope of the tangent line here at 1, because this was my 4, that is my c. Okay, so you would say, therefore, the slope of the tangent line of f of x equals the square root of x is also, what did we say, 1/2, because that's what our f of b minus f of a over b minus a is also, 1/2. Or maybe not say also, maybe just say is 1/2. So the slope of the tangent line of f of x equals square root of x is 1/2 at x equals 1. And that's what you're basically, the mean value theorem just guarantees that that is true. Okay, that you can find a c in your AB. So I found a c in my 0, 4. My c was 1, such that the